let's review an important topic when using microcontrollers, that of digital communication. The idea here is that we need to send data from one source to another, so maybe it's a sensor or an actuator that needs to talk to a microcontroller, or maybe the microcontroller needs to talk to a computer or another microcontroller. So the form would be digital communication, sending bits back and forth, and often every transaction will be 8 bits at a time. So 1 byte of data in each transaction, rather than sending 32 bits or something like an int, let's talk about like 1 char. So the main method, there's kind of 2 ways of doing this. It's parallel style communication versus what they call serial communication. So parallel communication is very pin intensive. If we want to send 8 bits of data and a parallel bus, we would need 8 wires. Each wire would carry 1 bit. And then you could read all 8 pins simultaneously to figure out what that byte is. Not very commonly used anymore because the serial method of communication, which means send 1 bit at a time over 1 wire, the bit rate can be increased. So we don't see many devices that use parallel communication anymore. Almost everything is serial. So serial means 1 bit at a time. There are many types of serial communication, and the big difference is usually, is it synchronous communication, or is it asynchronous communication? Sorry. So, asynchronous means that there is no clock. So if we're asynchronously communicating, right now I'm asynchronously communicating with you because I'm speaking at a certain rate and I'm not telling you when you should listen to me. You're figuring out how to do that yourself. So this means that it uses less pins to talk asynchronously. Synchronous communication means that for every time I send you a bit, I also send you a pulse, a clock signal, that tells you when you should read that data bit that I've sent. So different styles of digital communication. UART, SPI, I2C. These are the very common styles of digital communication you'll see in a microcontroller. The UART is the type of asynchronous communication, while SPI and I2C are synchronous. So that means that UART uses fewer pins. In UART you have an RX for receiving and a TX for transmitting, and then you'd have a common ground. For SPI you have a clock, often called SCK. You have a data in pin, DI, a data out, DO, and then we can talk to many chips, each chip requiring its own chipped select pin. So it takes 4 pins plus a common ground. For I2C, we have a data line, SDA, and a clock pin, SCL, and a common ground. So it only takes 2 wires to talk over I2C. So we see some advantages right away. In asynchronous communication, and I2C, only 2 wires. The asynchronous fashion of UART means that we can't often increase the bit rate too fast, because if I think you're talking at one rate and you're talking at another rate, and we're off by a few percent, we quickly lose the synchronous reading and writing. So this UART would be a lower speed, and I2C would be a higher speed. So UART might max out at, well, UART usually is very common, like 9600 bits per second. Another common one is 115,200 bits per second. I2C is commonly 100 kilohertz or 400 kilohertz, let's compare that to SPI. SPI has a clock line, a data in and a data out. So not only are we saving time because we have one dedicated line for data in and one for data out, compared to I2C, which has only one line for data, and sometimes it's reading and sometimes it's writing. But SPI can go up to 20 megahertz, sometimes even faster. Now I2C, we can talk to many devices using just 2 pins. For SPI, for every extra device you want to read from, you need another chip select pin. So SPI kind of uses the most amount of pins, but gets the most throughput. I2C kind of gives us a middle ground in terms of speed and small number of pins. And then we don't really find a whole lot unless you're talking to maybe another microcontroller or a computer. So most chips you might find, most sensors will be talking SPI or I2C. And we'll go through each of those in detail using the PIC32.